Welcome to Real-Time Signals Technologies. In this video, we are going to look at the various components of the Python and Numpy package. Okay, so Numpy is a fundamental Python package that is used for scientific computing involving calculations on large multidimensional arrays. It contains various data structures that can be used to store generic data, and it also contains sophisticated functions and a powerful multidimensional array object. Some of the supported array operations include mathematical operations like matrix addition, subtraction, multiplication, and the trigonometric functions. Logical or conditional operations, array shape manipulation, array sorting, and linear algebra operations. Okay, so Numpy's array class is called Ndarray, and so Numpy's main object is an object of this class. The Nd in the class name stands for n-dimensional, thus describing the main Numpy object as an n-dimensional array or a multidimensional array. Now this class is also known by the alias as array. But it should be noted that the numpy.array and Python's array.array are not the same thing, as the latter one handles one-dimensional array, that too with very less functionality. Now, in comparing regular Python arrays with the NumPy arrays, we know that NumPy arrays have a fixed size upon creation, and that a NumPy array is a table of usually numerical elements that are all of the same type. The elements of the table are indexed by a tuple of positive integers, and the additional attributes of the NumPy Ndarray object allow for advanced mathematical, algebraic, and scientific operations, among others. Python arrays, on the other hand, may be grown dynamically, like for example in the case of appending new items to a Python list. Some additional features of NumPy include the additional properties of the Ndarray class that enables it to provide larger, faster, and more efficient array sets than basic Python arrays. Also, we have element-wise array computations, dataset, reading, writing, and integration tools for C, CPP, and Fortran code. Okay, so NumPy uses standard data types that are already familiar to programmers who are used to with C, CPP, and Fortran, among other languages. And the string may be used to specify a NumPy array's data type at an array creation time. And you will either use standard Python types or a NumPy specific types. You may also obtain a NumPy array's data type by calling the dtype attribute on the array's associated Ndarray object. The table in the slide shows a sample of the standard types that you may specify, which includes Boolean, signed integer, unsigned integer, floating point, complex numbers, and the generic Python object type. Now, taking a look at NumPy array operations, we have the option of obtaining an Ndarray object attributes such as the number of axes or dimensions of the array, thus determining the array's rank. The shape of the array, which indicates the number of rows and columns in the array, the size of the array, which indicates the total number of elements in the array, the type of elements in the array, the size in bytes of each element in the array, thus indicating the array's memory consumption. And we can of course also carry a buffer containing the actual elements of the array. Although we won't normally do this, as we typically use an array's indexing facilities to access its elements. We may also perform joins or array stacking so as to combine several arrays into one array. Or we can do splits so as to split one array up into several different arrays. Stacks and splits may be performed horizontally or vertically for both single and multidimensional arrays. And as just mentioned, we may use an array's indexing facilities to access an array's elements so as to view or modify their values. In the case of a multidimensional array, there would be one index per axis. And we may also reshape arrays so as to change the number of elements along each axis of a given array. and we may perform a resizing by using an array's indexing facilities to obtain and configure smaller sub-arrays of a given array. Now the code example in this slide demonstrates some Python code in which the Numpy package is used to create a one-dimensional ND array object containing a list of integers. So in the very first line, we are importing the Numpy package as this object named NP. Then we have a commented line indicating the intention of the code section that follows. First, the Python list of integers is created using square brackets with each element separated by a comma. Then a new object named array_1 is created with the purpose of storing our NumPy array. The NumPy array is created by calling the array method or function on our NumPy object NP, and the Python list of integers is passed in as an argument to the function call. After that, the name of our new NumPy array is typed and entered at the prompt. And in the following output line, we get our NumPy array and its elements being printed back to us on screen, thus confirming successful creation of our integer NumPy array. So that's it. In this video, we have looked at the various components of the Python NumPy package. Thank you.